Alright, welcome to the new episode. Um, like you know, my name is Abel Gray Cantoma. Alright, here now, I'm going to be designing a steel roof, but we are actually going to be importing uh, this roof. We will import it from the AutoCAD. So, you can see this is the cross section we want to import in AutoCAD. So we are going to reproduce this exactly as it is. We'll draw it in AutoCAD here, then we will import it into our Prota structure. So I will first of all share my screen here into two so that I can simply just, because I'm sure this drawing is not drawn to scale. So normally we do our structural steel detailing using AutoCAD manually. So I'm going to be using this right now. I don't think this is drawn to scale. This is supposed to be 4248 4248 4248. So I have 4248 in two places. Four two four eight multiplied by 2 to be 8496. So I'm going to just draw a line. I'll put this on auto mode. Offset. Eight four nine six. 8496. Although you are not supposed to really come up with this. The architect is supposed to give you the cross section, but I'm redrawing this because I'm sure this is not drawn to scale, so we can't use this at the moment. So I'm going to just sketch this. Okay, so it's just the truss alone we can import actually. We can import only the truss. So here now, I'm not sure of this height, but let's say this height is 3 meters. I'll make it 4. Then I'll have an offset here 600. So I have this. Okay, let's say this is 1000. sorry. Extend. So let's say this is what we have. Like I said, I'm not sure of the height because I've lost this architectural drawing a long time ago. I can't locate it anymore. But if this is correct, all I need to do is to know the architect will most likely specify the width, that's the spacing for your pole line that you should use, probably based on the type of roofing sheet that will be used. Okay, so let's say I have this. Sorry, I'm going to give this a color of this one another color like this. I think this is way bigger than 600. No, this is not what I want. Offset 600. So I'm just going to quickly model it. Alright, so let's say we have this. I can simply just mirror this. I'm going to mirror what I did here. So but you don't have to do this yourself. The architect is supposed to provide the cross section for you. Okay, so once this cross section has been provided for you, all you need to do is just to clean it very well and make it in a single line. Okay, so if you can just make it in a single line like this for the structure to be able to actually interpret it well. And then if you look at the plan view here, from what we have a support at 4248. So I will offset 4248, enter. So I'll do similarly for this as well. Then I will extend it up. So this is the warehouse that we want to reproduce. This is reinforced concrete, so this is not relevant for this particular training. So this is just what we are going to be capturing. Okay, so if all of this is complete, we can then go into then we are going to import this into our ProtaSteel structure. So to do that now, all I need to do is just to copy this, and then I will highlight this. Okay, let me have another one here. Alright, perfect. So this is the steel cross section that I need. So I will highlight, and then I will make it a DXF. So I will name this Prota cross section, Prota cross, and I'll click OK. So I will look for it, and I'll convert it to a DXF file. Prota. Sorry, let me just search by cross. Okay, open file location. This in document, so I'll open it. And I will save it as a DXF file. Alright, then I'll right click here, I'll save as, and I'll use save it as a DXF 2007 DXF, and I'll save. So I'll go back to my Prota structure now, and this one I'm going to save this work. This is the previous model we did, so we are going to do all the modeling that we need to do, all the necessary modeling that we will now analyze, you know. So let's come to new project, and similarly, just like we did before, here I will name this steel roof. Click OK. Alright, so the next thing here I'm going to do is to create my grids. Okay, so I will look at what I have in my AutoCAD drawing, because like I said, I want to reproduce these drawings. Okay, so I have 5 supports. I have 5 supports here. I have one here, I have one here, one here, one here, one here. So which makes it 5. So at an interval of 4 to 4, 8. So I'm going to create 5 grids. I'll use this. I'll hold on Control to have a straight line. I'll right click on it, and I'll offset. So I'm going to reconfirm the width of this 4248. Sorry, F2 4248. Enter, and then since this is what I have, then along this part I have these as it's not this span is not regular, so let's just have a more regular span, because this is not supposed to be very irregular like this. So let's just have a more regular span here. So let's make it 5 meters, 5 meters, or 4,500 meters, 4-5 spacing. Let's say 5 meters. Okay, 5 meters is okay. 1, 2, 3, 4. So I will make 5 meters interval here. Oh no, I don't want to use orthogonal like this. Read, hold on control, then I will offset this f2 5 meters, 5 meters, 5 meters, 5 meters. So I have 1, 2, 3, 4. So this is what we have. You can as well just move this a bit. I'm gonna leave it as it is. So basically this is what we have. This is our model. This is the axis rather, and this is a very simple design, very simple, very simple and straightforward. All we need to do is to insert our story. I'm going to insert 2, and I'll click OK, and I'll click yes, and then I will come to my stories and I will click on edit story. The first one, I'm going to make it let's say 500. So but let's see if we can find the height of this. It makes it way more easier. The height of the building is not there, but you are supposed to get the height of the building from the architect as well. So if you know the height, let's say the height of this building is 6 meters. Of the warehouse is 6 meters, aside from the concrete column. But if the overall height is 6 meters, all you need to do is just to make this 5,500. Okay, so then if I come to story 0, 1, story 1, I will insert my column. Let's say, because there is no support in the middle, this steel cross section, we only have at the edges here, we have then, but at the middle is void from what I'm seeing here in the architectural drawing, in the plan, from the plan view of this drawing. So there is no support at the middle anywhere. So that will most likely make these steel cross sections to be a bit more bigger than usual. Okay, so all the loads are being carried by these stanchions at the corners, and then we have some here. So we are going to, let's say we have a, yeah, let me leave it at 400 by 400. Then I will insert mind you, we don't have, you can see I'm just inserting them randomly without really even taking note of their numbers. Okay, but you can rearrange them in ProtaStructure. ProtaStructure can help you to really rearrange all of these for them to actually come out well. Okay, that could be rearranged. So if you click on you can delete unused axis if you have, but I don't think we have any here. You can fix the almost orthogonal axis, you can fix them, right? Then you can relabel the members, so you can relabel all these members. The software will just help us relabel them. So this column that I did not really put well, so it will label from left to right. Okay, so if you check that now, you are going to see that has been rearranged. 8, 9, 10, 11. Okay, perfect. So I will go to my story 2 and I will do similarly for this. All I need to do is to pick on my steel columns, and then I'll place those columns in their positions. Then you can see I just inserted them. So the same way I can just rearrange my columns. The software will automatically arrange them the way it should be. I always like to have two views, one plan view, the second one 3D view, in order for me to see what is going on in real time. So then you come to view here, make it to vertical, tile vertical. Okay, so if I have this like this now, remember we said this steel cross section, for example, like I said earlier on, there are cases where you have a steel cross section that may be, but you know, this one is not really unique. Nothing is not really unique per se. We can easily even find it here that is similar to whatever we just modeled now. But I'm just saying, in the case where you have a steel cross section that is a bit more complex, that you have to import. Okay, so but if you want to really spare yourself, yeah, it's easier to really even do your steel, you know, cross-section drawing in AutoCAD, because you know AutoCAD is a very flexible tool that you can use to achieve whatever you want to achieve way more easier and faster. So there, to import, all I need to do is just to select two like this, then it brings me here. Sorry, I'm going to take that part again because I know it's going to be a bit confusing. I'll click on trust, then I'll click here and I will click on this other one. The moment I click this, I can click on import from DXF. So once I click on import from DXF, remember the file was saved in my document and I named it ProtaCross. So this is the file and I'll click on open. Alright, perfect. So you can see this is the steel cross section that we modeled in our Prota structure. So what we need to do now is to assign them in terms of a top chord, a bottom chord, a horizontal chord, and a vertical chord. So if I click on, now it's asking me to import start point. Okay, so if you come here from our AutoCAD drawing, if you can see that start point should probably be where we are going to be having a support. So you know, we have a support. Shit, I've really messed up this thing there. That should probably be almost at the center of this. I did not. Okay. No, I messed this thing up. Okay, but let me pick here, and then the endpoint, let me pick here, and I will import. So I messed up the whole thing. Where I'm supposed to have a support, okay, so you can see it's showing me support, although it's not correct. My support is around here, so it's not really going to come up well for me the way I want it. So let me see if I can do something about this. Offset 600. Okay, offset 600. So mind you, I can delete from the software. I pray it recognize this. I'll delete, but I'm going to remove this. I'm going to remove it. Definitely I'll remove it. So I will save. Yes, I'll replace it. I'll come back to my Prota structure here. I'll cancel this. I will try to re-import it all over again. Sorry, this is not what I want to do. I will click on steel truss. I'll click here, and I'll click here, and I'll come to import. I'll go to Prota cross. Perfect. I'll pick my point, and I'll pick here my endpoint, and I'll pick here, and I'll click on import. Alright, good. Now I can delete this. I can also delete this. Alright, good. So I can now highlight and assign it as a top chord. You can see top chord is green, and this is what we have, our top. Okay, so I'm going to set as top chord. I'll click this, and I'll set as top chord. I'll click, and I'll click, and I'll sorry, I made a very big mistake, but it can be corrected. I'll just set as a bottom chord. Then I will select all this vertical, so after selecting all the vertical, I will just right click, and I will set as vertical chord. So similarly for the diagonal chord, I will select them, and I will assign them. Then I will assign it as a diagonal chord. Okay, set diagonal chord. So if all of that being done, you can simply just create some more points, divide a frame, add extension points, measure a distance, you can stretch, you can do all of that to all of these structural members. Okay, so if I want to create a point, all I need to do is to click on create points, between 2 points. Okay, I'll probably demonstrate that in the course of this training I will demonstrate that. Okay, so but right now I'm going to click on OK. So you can see that has been created automatically for me. I can just rotate this and place them everywhere I want them to be. So irrespective of your steel cross section, no matter how they come, you can as well simply just create it from your AutoCAD and import it into your Prota structure. Now it's a good thing that this is like this. All you need to do now is to increase this height, increase this height, increase this height. So let's say I right click and I come to the property of this. At my DZ top here, I will increase this by I will have to know what height is this. I don't want this to clash, so to measure this I'll right click click on measure. You can just simply check the height. So the difference is in 1,500 although we can as well even correct that even in our ProtaSteel. Okay, so but let me just specify the height here and increase it by 1.5. Okay, so this has been increased by 1.5. Sorry. You know, you have to create like a base plate to carry this. That will be done in ProtaSteel. Uh, 1,450. 1,400. Okay. So you can do similarly for all of them. So but let's check the measurement for this. This is 2,775. So I will take this to this, hold on control, select the both of them, 2,775, 2,775, click on OK, close. These other two, select, come to property. This will be 1,400. All right, so here I will create a pull line and do all the necessary settings just like we did last time, and I'll create a GAT connection for this. Similarly for this as well. Then create a brace. So let's say we are going to be having maybe like an opening, or let me just leave it like this. Let's brace it this way. Let's just brace it this way. So but however you want to achieve this, it can be done. You can actually manipulate it to whatever shape, whatever size, whatever height you want to achieve your model. Okay, that can be achieved from the Prota structure, as you can see, obviously. But then I needed to create a beam, which I actually did not take note of from the beginning. I needed to have a beam here. No beam overlapping. Do you want to split the beam? Okay, so this is a warehouse. I can simply have a gut here as well, you know, have another here, and then this could be just like an opening. Have a gut here, have a gut here, and then I could even brace it. Can brace it. All right, with that being done, we can as well brace these. We can brace these, then probably brace here. Okay, so once you are done with your model, all you need to do is just to click on analysis and design. So like I said, we are just going to have all the set of our models, separate different modeling that we are going to do. We'll have all of these models, then we will now come back to analyzing them. Okay, so we will first of all do all the necessary models. Like I said, modeling actually is like takes like 80% of your job already. Once you are done with the entire model, you have actually taken care of probably more than 80% of the job already, because all you need to do next is just to come to your analysis and click on analysis. The software does all of that in the background for you. Okay, so all you need to do is just to run the analysis, know the right steel cross sections, because by the time it analyzes it for you, you can just play around with your utilization ratio, your slenderness ratio, in order to strike a balance in between them. once you are able to strike a balance, that will definitely be the most economical and safe. So you have a steel cross section that is the most economical steel cross section. So the software is there to guide you to adopt the most economical steel cross section. So most of these cross sections that we picked from here will most likely change a lot, most of them, by the time this software analyzes it for us. We'll be able to tell from the analysis report, we'll be able to tell if the steel cross section is okay, if it has failed, or it is too high. If it is too high, we reduce it. If it fails, we increase it, and all that. Okay, so I see you in the next section.